All right, so what we're going to be talking about is we're going to be talking about balancing redox equations. Now, what does that mean? Step one, let's talk about the first reaction we saw in the lab. All right, we have nitrate going to nitrogen dioxide. What immediately is wrong with that? Something should jump out at you. If you look at that, you know, knowing what you know about atoms, what's immediately wrong with that? Marie-Ange. Not necessarily, but what's the big jump out?
You're missing that.
I lose an O. I can't just say, hey, I started with 3 O's, I've only got 2 O's. Uh-oh, right. They just don't go away. It doesn't work that way. So let's look at what we got to do here. We remember, please, that we are in a water solution. Okay, this was in a water solution. So we have available to us water. We have available to us hydrogen ions. We have available to us hydroxide ions. You might have learned last year that water, just sitting there, will split up and make hydrogen ions and hydroxide ions in small quantities. If you didn't learn that, don't worry about it. There are little bits of hydrogen and hydroxide in water. All right, so we're doing this in an aqueous solution. So now, there are some steps we go through to balance this thing. We've got to get this right. And so we can't start with nitrate ion and go and lose an oxygen to someplace else. It just doesn't work that way. So here's what we're going to do. There are 4 or 5 steps. Step 1, we got to have the same number of all the other elements besides hydrogen and oxygen. So step 1, we've got to balance like everything but hydrogen and oxygen. Well, how many nitrogens on each side?
1.
1 and 1. So that's good. Okay. Step 2, we're going to balance the oxygens with water. Okay? So how many oxygen do we have over here?
3.
3. How many over here?
2.
2. So how many more oxygen do I need?
1.
1. So we're going to add water. Okay? Now, that messes something else up. What do we need to fix next? Okay, so we're going to balance hydrogens with hydrogen ion. All right. I'm just going to, I think I've run into a box here. I'm going to move this down just a little bit. Okay, how many hydrogens do we need?
2.
We need 2. So I'm just going to stay with my color scheme. We're going to need 2 hydrogen. Okay, now looking at that, does it look balanced? Do we have the same number of H's, same number of O's, same number of N's, but there's a problem. The charge. Okay, if you look at this side over here, this molecule has no charge. This molecule has no charge. This molecule is -1. These are a total of +2. There are 2 of them at +1, therefore +2. Right? So this whole side has a charge of 0. This side over here has a +1. So we need to fix the charge. So how do we balance charge? What is our currency in chemistry? What do we move about? Electrons. So how many electrons do we need to add to which side? Nothing? 1. Where does the electron go? To make them the same.
The reactant side.
How many?
1.
1. We need 1 electron added to the reactant side because -1 + 1 = 0. So we have to make the 2 sides the same. They don't always equal 0, but they're going to be the same. Okay? So now we have this, what's called half reaction, done. Why is it only half a reaction? Where'd we get the electron? That's the other half reaction. The electron had to come from, where did it come from in our chemistry? This is the very first step of the lab. Where did the extra electron come from? What? Came from copper, right? So let's look at the other half reaction. Copper goes to copper 2 plus. We know it was copper 2 plus because it was blue. So let's check the steps. Are the coppers balanced? 1, 1, right? Any oxygen?
No.
Any hydrogen?
No.
Now we balance the charge. 0 on this side, plus 2 on this side. How many electrons do we need to add to which side? 2 to the right. Okay. Now, those are the two half reactions. So if we want to say really the whole reaction, what chemically really happened, what do we have to do? Well, how many electrons is copper giving away? 2. How many is each of these reactions taking? 1. So how many times does this reaction have to happen compared to the number of times this reaction happens? So for every 1 time this happens, this will happen twice. Okay? So in other words, this whole reaction is going to happen 2 times every time this reaction happens once. So what we're going to do is, in balancing terms, is we're going to look, and this has got a coefficient of 1, coefficient of 2. What's the smallest thing that 1 and 2 goes into? 2. So we need 1 of these, and we need 2 of those. Now let's do the count. Let's do it all the way up. We're going to add these 2 things down. Everything that's a reactant over here, everything that's a product over here. So we're going to have 2 electrons, 4 hydrogen, 2 nitrates, and 1 copper. Goes to 2 nitrogen monoxide or dioxide, 2 waters, 1 copper ion, and 2 electrons. Now, is there anything that's redundant? Is there anything that's redundant? We started with 2 E's, and we ended with 2 E's. We can't have just loose electrons running around here. So the idea is we have to get it so we're just talking about atoms and ions. So this reaction says that 4 hydrogen and 2 nitrate ions reacted with 1 copper atom to make 2 nitrogen dioxides and 2 waters and a copper ion. And notice that answers your question as to whether we'd have some extra leftover hydrogen. We had a lot of extra leftover hydrogen because we were putting in nitric acid, which is one of these to one of those. So that's why we had to put in a base to neutralize it. Question?
Sorry, can you just say why you crossed out the 2?
Okay, because what we're going to do is in any reaction we're going to say, okay, if there's anything with which we start and we end with the same stuff, it should go away.
Okay.
Or say in another example, we'll have, say, started with some hydrogen ions, end with some hydrogen ions. We'll cancel out any excess.
Okay.
Drew?
How did you know that that reaction would happen twice for every time?
Okay. The reason, the question was, how do you know it happens twice? Because this one's giving away 2 electrons. Each of these is only taking 1. Give you a stupid example. Ready? Supposing you guys are little kids and like ice cream, and the ice cream truck just pulled up down the street, and you come to your adults and you want money for ice cream, right? I've only got $2. Haven't been to the ATM. Payday's today. I haven't gone cash my check yet, right? So I got $2. Ice cream, everything's $1. So how many kids can I take care of? Just me. 2 kids, because each one needs $1, right? So for just me, these two are going to get ice cream. For the next me, well, more than one me, that'd be scary. Multiple me's, I could take care of these two kids. Multiple me each time there was one of me, two of them would get ice cream. Okay? Look here. This copper, by disintegrating, gives away 2 electrons. This reaction requires 1. So for every one of these that happens, we double this to get the same number of electrons taken in as were electrons given away. We'll hit the red button.